Now, I brought in these two ions because they confuse people. Okay, and I wanted to make sure that you know what is going on here. People see this prefix di and they start to think, oh, is that a covalent compound? Although we are using the prefix di, this is not a covalent prefix. So it's not a covalent compound. Okay, it's called, we've got a chromate ion, which has one chromium, and it is bonded to 4 oxygen ions. Okay, and that is chromate. Dichromate is almost like you took 2 chromates and stuck them together, but you got rid of one of the oxygens in the middle. So you can imagine if you had this oxygen attached to, another chromate's to another chromate, but that there was an oxygen that got left out in the whole process. So we go from CrO4 2- to Cr2O7 2-. I want you to remember to always look up dichromate. Okay, if you see dichromate, it will be under D on your polyatomic ion chart. Polyatomic ion chart. Because otherwise people start putting, they'll be like, oh, I've got chromate, CrO4, and so I'm going to say I have 2 of them. That is not dichromate. Okay? Dichromate is Cr2O7. It's not 2 CrO4s. All right? Dichromate is not 2 chromates. So just remember to always look up dichromate. It's not 2 chromates. I will try and remind you of that as often as I can. Okay, we're going to just do a little practice on naming these. All right, you're not expected to be able to do that at this point. However, this will give you a preview of what you will be doing very soon. When you get polyatomic ions in a compound, they start to look really complicated, yeah? But remember, anytime you have an ionic compound, it is always going to be a cation plus an anion. Okay? And if we look over at this guy here, here is our cation. That means that everything else has to be the anion. Okay, so when we name this, we're simply going to name our cation, and our cation in this case is Na, which is sodium. And we are going to name our anion, and we just learned that CrO4 is named chromate. The endings of polyatomic ions do not change, okay? It's not like you would all of a sudden call it chromide. Polyatomic ions, you just name them as they are defined for you on that chart that you are going to get, okay? All right, we have our next one. We have Al is our positive ion. That means that the CrO4 is our negative ion. And so that will be aluminum chromate. Do either the sodium chromate or the aluminum chromate, do they need a Roman numeral? Do they? And the answer is no. Okay, neither sodium nor aluminum are in the red zone. Therefore, no Roman numeral. Whoa, Miss Spence, I have lost my periodic table with the red zone. It is posted on Schoology, and I will make sure I also post it on Teams. Okay, I'm going to put it in our file in Teams, so you can go to, I think it's class materials, or I think it's called files. Okay, so you can go to our file, and there will be a file there that says periodic table with red zone. Okay, and you can download that for yourself. All right, now for our next one, we have Cu, which is copper. That is our positive ion. Our negative ion is the CrO4. Cu is copper. Now copper is in the red zone, okay? So it's going to be copper something chromate. And just pause your video for a moment, and I want you to tell me, how many chromates do we have here? How many chromates are in this compound, in that formula? How many chromates? There is only one. Okay, there is only one chromate. This 4 here, okay, that doesn't mean that there's 4 chromates. What it means is that in a single chromate, you have 1, 2, 3, 4 oxygens. Okay, if I actually had wanted to have 4 chromates, I would have to say CrO4 and put it in brackets and say I have 4 of that entire thing. Okay? So remember, unless it's in brackets, you only have one of the polyatomic ion. And I'm sitting here making all these lovely hand gestures that you can't see. That's all right. So I have one chromate, CrO4, 2 minus, and I have 2 coppers, Cu, Cu. I want the total charge of my compound to equal 0. What that means is that each of the 2 coppers have to be +1, because then I've got +1, and -2, and overall that will give me 0. And so that's going to be copper 1 chromate, because remember, the Roman numeral represents the charge of a single ion. Okay. Let's go over here and take a look at this one. We have titanium. Titanium is in the red zone, and that is our positive ion. That means that everything else has to be our anion. Okay? Titanium is in the red zone, so it does need a Roman numeral. And Cr2O7, I would be able to look that up on my chart, and it would be dichromate. Okay. How do I find the charge of my metal ion? Step 1, I draw out how many I have of each. So I have a titanium and a titanium, 2 titaniums. And I have 3 dichromates. So I'm going to draw 3 dichromates. Cr2O7, Cr2O7, and I will be able to look up the charge of the dichromate. Each of them are -2. So step 1, draw out all of the ions so you have the correct number of each. Step number 2, add up all your negative charges. Okay, and so that's going to give us -6. Step number 3, your total positive must equal your total negative. So positive charge will be +6. Now remember, I need to have 2 things add up to +6. So each of these will be 3+. So that means that I'm going to have titanium 3 dichromate. Okay. Whew. K, oh thank goodness. K is not in the red zone. It's in group number 1. Group numbers 1, 2, and 3 are not in the red zone. And so I'm just going to name K, which is potassium, and Cr2O7. All of that goes together. You're never going to have like 3 different things that you're naming. You're always just going to name the cation and the anion. So you should only ever have 2 names. Okay? Cr2O7 is dichromate. All right, our last one I put in there because it looks funny. Okay? We have Cr2O7, and I'm like, oh my gosh, which one is my cation? If you have a metal, okay, that is your cation. That's it. Don't try and attach it to the next Cr, okay? Metals in cations are just on their own. They're not, there's no polyatomic metal cations with one weird exception we'll talk about later, okay? That means everything else is the anion, okay? So we have chromium, which is chromium, and it is in the red zone, so we need a Roman numeral. And how many dichromates do we have? Pause the video and answer that for yourself. How many dichromates? Because there are no brackets, we just have one dichromate. So we have one dichromate. Remember, draw out how many of each ion you have, Cr2O7. And you look up its chart. It is 2 minus. And how many chromiums do we have? We just have 1. Okay, so these chromiums are part of the anion. This chromium is the cation. And so in order to have an overall charge of 0, this chromium has to have a 2 plus charge. 2 plus and 2 minus gives us 0. So this will be chromium 2, okay, chromium 2 dichromate. All right. Special note. Oh my goodness, I told you I'd tell you a lot. Dichromate is not 2 chromates. Oh, that's supposed to be a highlighter. Dichromate is not 2 chromates. Don't forget, okay? Not 2 chromates. What should you do when you see dichromate? You should look it up on the chart. Okay, so barium dichromate is barium dichromate, not barium with 2 chromates. In fact, this compound couldn't form because barium is not in the red zone. Its charge is 2 plus. Chromate is CrO4 2 minus. You would not have a compound that had 2 chromates with a barium, because otherwise, if we did, our positive and negative charges wouldn't cancel out, and so that would be a problem. So when they actually react together, we end up with just barium chromate.